Hello and welcome to the EEPROM 9, complete with flicker from Retro Tubes. We're going to do the repair of the vintage calculator and give it a new VFD display. Now I'm keeping this video as short as possible just for sheer simplicity, so I don't have to keep running upstairs and changing it. So pretty much I can do it in one shot with just a lot of stopping and starting. So this is going to be a best by best tutorial. I've got all the equipment I need, I've got my projects book. I'm also going to put a whole host of information about VFDs, so if you don't know what these things are, I suggest you read them before watching this video, or you're going to get very lost on exactly what I'm doing. I'll do a separate video on VFDs if you want me to. So this is a little introduction to what we've got. Now this is set up in the kitchen. My parents are on holiday for 2 weeks, which means the house is pretty much mine. Which is the perfect time to set this sort of stuff up, where they can't complain about it taking up the space where the washing is normally dumped. So we have 20-year-old oscilloscope, brand new soldering iron station which I've used once so far. Vintage voltmeter, gain phase meter which has no real use for this particular project but is just being used, going to be fixed next, and power supply, ESR meter and both my multimeters, both my good ones. And we're pretty much ready to go. So I guess we start with testing the VFDs. Okay, so here I'm basically probing the calculator, just checking that the logic works, and when I put the probe there, we have signs of life, which come up when you put it on certain pins. Now this thing doesn't have a mask or whatever the sod it's called, I've forgotten what they call it now, shadow mask or whatever. Be careful not to short it out. Ah, that is interesting. Only a few volts. Unlike over here. But yeah, that's the next stage, and then I'll get onto testing that VFD. I'm just trying to figure out what's what on this one. For visual inspection, and gravity's being utterly... Oh, fuck's sake, more receipts. I'm sick of receipts. I'm mapping out what it says on the board and mapping out exactly what it is. I've found the heater, which is the good part. There's a little filament inside VFDs, acts as a cathode. So, I've had to replace the pins, the last one's all leaky and horrible. I'm remoting down the other thing, then I'm going to key it, and I want to work out the grids. Now this broken tube I might actually have to break open to actually figure out exactly where everything is, but it's dead so it doesn't matter. The nipple was actually broken off. Glass is broken, I'll put it off at some point. I'll probably actually break that tube so I can do some actual continuity testing. See you in a bit. We have now removed the broken VFD, the nip fell off. And so now we need to trace it, and I think I'm going to have to crack it open to reveal exactly all where that goes, to which grills they go, and so on and so forth. Right, I better find a small, reasonably hefty tapping device to break this glass envelope. And then I can start plotting out the pins. But so far so good. I'll have to do some logic checks to check the calculator's still good. Over and out. Curse me if one must, but I just cracked this open so I can get my multimeter and start continuity testing this little VFD tube. Don't worry, it's the broken one. Because when you're breaking something for education or something, then it's not such a bad thing. But look at that. Intricate beauty. Now it'll be a lot easier to tell where this filament's connected to. One good thing is the techies, if you look here, the people who designed this, if you look here, there's printing on the board around these ports. They were nice enough to give us labelling of what is what, which is really helping the situation. Plus with my tracing out, I've just found the anode grills 5, 6, 7 out, found 1, 2, 3, 4. I'm starting from left to right. And so we are going brilliant. It's a shame I had to smash this tube, but my grandfather would be proud that I used his old tools. Sadly he's not around anymore, he died before I was born. I reckon he'd have been really pleased to see an engineer in the family. It looks like we might be able to get this working tonight. The next part will be working out exactly the layout, but that seems to be marked out. Working out that's going to be harder. I hope these segments, because I want to remove one of the grills and then probe it with the multimeter. But yeah, if you want, I'll give you a full overview of this when I do an explanation of VFD. So I'll put it to one side safely and out the way, so it doesn't get any more damaged. Because the poor thing has had a bad day. And the new one's a lot smaller, but as long as it fixes it, that's all really matters, isn't it? Anyway, that's all for now. How are we doing on time? We're doing okay, actually. Okay. Okay, I believe I've reverse engineered the circuit board of this thing now. Turn it off, save batteries. So we've got our grills here. 1, 2, 3, 4, 5, 6, 7, 8. We've got heater filament there, and the rest are our segments. So I'm going to take this tube, get it powered up, work out what's what, and get it all sorted. See you in the next stage. It's going well, and I've got my geeky lab coat on, just to add to the geekiness of this whole operation. Oh, it's really geeky here. And the dog's outside currently in the garden, just having a nice little stroll in the sunshine. Yes, it's sunny in England. Can you believe it? Such a thing only happens on rare occasions. Anyway, I'm wasting memory. I don't know how well you can see this, but if you look at the little VFD in my hand, you should be able to see it's lit up. I can see it on the camera, so you should be able to see it. Okay, now it's just figuring out the pin out, which is actually quite easy on these things, although with both pins all on one side it is slightly awkward. I'm first going to work out the anode grills. Place them in the sort of order that's seen on here, give them the same sort of wire colour as this, then we'll be good to go pretty much. Hopefully I can use these same wire colours actually. Yes I can, excellent, good. Good, I can pull them off and put them on then. Goody good, good. Okay, I'll see you in the next bit when I've got this sorted. So far so good. We're going to have this thing up and running, hopefully tonight. I'd love to have it up and running tonight and just do a lovely video of the After Effects. I don't know whether it'll have any other problems. We'll only know when we get the display installed. Thanks for watching so far. Update on the project. I have soldered in connectors so I can do plug and play for any mistakes that might be made, because I don't want to keep soldering and desoldering from this board in case I damage it. And I've almost completely reverse engineered this VFD. So, overall progress, going good. It's just a time consuming process of reverse engineering this VFD, checking it, doing a few solder across bridge connections and stuff like that. So, you should see me on the first stage of testing, really. Testing my work. This has definitely taken up the whole of the afternoon, since like 3 o'clock, and it's now about 8. My brother should be home by now, but he's not. Anyways, back to testing. Right, now for the moment of truth. Will it work? It works! Although we have got jumbled up characters, but that's not the point. 6, 6, 6, 6, 6, 6, 6, 6. 6 is displayed correctly. What the hell? 1, 1, 1, 1. One's not displayed correctly. 2's not. 3 is. 4 is. 5 is. 6 is. 7 is. 8 is. 9 is. Ha! We have made progress! It lives! Although, be it we've got a bit of a mess up in the characters somewhere, it's something to do with. We've got G and what's the other one? G and C mixed up, so G is here and C is here. Hang on, fucking phone. I hate the fucking phone. Right, there's only a few seconds left of this, but it works! I fixed it! Look at that! Beautiful! Thumbs up! It lives! Now I just need to get this VFD back without knocking out any of the connectors. Look at that. So we press 8 repeatedly. Beautiful. Thanks for watching. So I suppose it's only right to have a conclusion of the calculator project, because now I've got it cased up. And there's some good news and there's some bad news. So let's start with the bad news. Because of all this, my room is an absolute bloody mess. I've got the cupboard pulled out, I've got stuff on the bed and other crap. The good news is, there we go, the captive charger. It works. Oh god, what the hell just happened? I don't know. The battery is a bit crappy in it. Oh god. The battery connector needs a bit of work, but other than that, it works. Oh god, it just keeps resetting itself. But it works! It works! It's sodding bloody battery. Come on. Okay, so the battery connector. Bit of metal, bit of metal, bit of metal, bit of metal, and I'll fix that right now. What have we got in here? Aha! Perfect. So we're just about to fix that now. This is the metal you can cut. Hang on, let me get this. And I'm back. Some of you will probably think, oh, I read it out. Nah. There's enough editing to do this video and sticking all the other bit together. So, in my ingenious wisdom, I have grabbed a bit of metal and I'm going to jam it into the battery connector. It is as simple as that. It seems to have had a short circuit in it at some point, and I just dropped the battery thing on the floor. Just shove in there. I'll do it on the negative end then. Why is it so bloody hard to shove something into a hole? There we go. Let's get colour. Jam that in there just a bit more. There we go. Get that on. Ta-da! Oh, good as new. Complete with Tesco's rechargeable batteries. So we can do 8888. Add 8888888 equals. Too high for it. 5 add 5 equals 10. Excelentes. question is, which is better? My Commodore calculator, which is floating around somewhere. Actually, that's a good point. Where is my Commodore calculator? I have brought it back because I brought everything back now from uni. I do have some videos from uni to actually upload that I haven't uploaded yet. But I am officially back home. Whee, look at that! Love the refresh rate. It's like one of the one things you wave in the air and it makes patterns. But yeah, good news, fully functional. Bad news, I got a mess to clear up and I got a load of washing to put away. I put the batteries back in the Husky Hunter that I pillaged the batteries from for testing this. Some of you might wonder why there's a missing segment in the middle. That is because it's a 9-segment display and that's all I could get hold of that would fit this and was within my price range. So that was all I could get, so that's all what I made do. I did want to leave off a segment at the end, but the design of the actual tube inhibited that from being really practical. So instead we've just got a gap in the middle. It's a little quirk that's quite easy to get over and it makes it look unique. So that's the Royal Digital 5T calculator, fully restored, and I hope to have this video uploaded reasonably soonish and be back to regular videos because I've been off them for a while because I've been busy getting basically shit sorted from uni, pretty much. The stuff sorted. That's what I've been doing pretty much. And Portal level building. There'll be a link to my workshop once again down below. Play to your heart's content. I've got 2 more levels. I've completed the other level I actually did a video on, and I've since done another one which is really quite cool and you're one of the robots. Thanks for watching and I hope you enjoyed, and well, from the Royal Digital Calculator, goodbye. Found it. It was in the garage in a little box that I'd stashed it in. Yay! They look so cool next to each other, but which one is cooler? I think I'm going to have to let the viewers decide which one is the most geeky but awesome at the same time. Thanks for watching.